All right, good morning, everybody. My name is Nico. This is Michael. This is Zach. This is Martin. Together, we made an FPGA cryptocurrency miner. So a little background on cryptocurrency mining. It's basically the verification of the cryptocurrency transactions by computing a very complicated math equation. And the main ways that they solve that right now is through graphics cards or ASICs. The problems with graphics cards and ASICs is graphics cards use a lot of power, and ASICs aren't readily easily changeable to adapt to new hashing algorithms. So we implemented the hashing algorithm onto an FPGA in order to hash the cryptocurrencies in a more efficient way that we can rival the speeds of the GPUs and ASICs while also reducing the power and increasing the efficiency.
Yeah, so in specific, what we did was we took a secure hashing algorithm, SHA-256, which is very common. We ended up researching a whole bunch of different currencies, a whole bunch of different algorithms, and we determined that we would go ahead and try to implement this hashing function on a very high speed, very expensive FPGA. So we ended up settling on, after a whole bunch of research, this algorithm with a Vertex 7 FPGA. We ended up implementing an open source SHA-256 module, and we ended up creating several finite state machines to iterate over this SHA function a whole lot of times per second. So the whole goal here is to essentially make it so that we're able to rival the efficiency of a GPU while also being able to change quickly, because it can cost $500,000 to $1 million to make a new application-specific integrated circuit, or an ASIC, which is what they call it. So in doing that, we ended up implementing that, and we were able to put over about 80 parallel instances of this hashing algorithm on the board. So
yeah, with all of those 80 instances, with just one instance of the hashing algorithm alone, we were seeing around 660 kilohashes per second. And once we threw around 80 instances on there, we were actually about to see it was competing with some of the high performance top tier GPUs like the GTX 1080 Ti's. And really the only limiting factor of using just this one very expensive board was the amount of logic that we were able to put on it. With 80 instances, we maxed it out, and we were able to successfully compute 80 instances of the hashing algorithm all at once.
Okay.
Still have time?
yeah.
It's about time for questions.
So questions?
So if I understand this correctly, you guys have built a board that you can use on multiple cryptocurrencies, is that?
Not quite, but that's a great question. So we built the actual firmware, the VHDL code, to be able to go and throw this on whatever board we choose to implement this on. So our entire project is essentially, we have this algorithm, we take a message signal, or whatever their big address block, and we go and iteratively hash this. This is essentially what the blockchain is all about.
Have you tried it on any one of those, like Bitcoins or
And
Ethereums?
so that's a great question, and so that would be one of our future things, which is what we didn't quite get to. And our next future thing would be to actually hook it up to like a coin, like a Bitcoin, or using CG miners.
So how can you say the result is like low power consumption, higher efficiency, surpassing that of? So what's the, have you practically tried it and see?
Yeah, that's a great question. So using the power metrics from our design software, we're able to compare the actual efficiency of how fast or how many hashes per second and hashes per watt we do with our algorithm versus known standards for GPUs and ASICs using the same algorithm. So in effect, we're able to compare one by one how our algorithm does compared to them.
So one of the criticisms of cryptocurrency mining is the huge amount of current that's used. Does this help cut the amount of current that's required?
That's an excellent question. And initial data shows that our algorithm is 10 times as power efficient as a GPU. The drawback is that an ASIC is so much more power efficient than anything else. But this gets a little more technical in that sometimes a cryptocurrency will change the way the algorithm is made, and so you have to go and develop an entirely new ASIC. So there's a lag time where the only thing you can use to mine is a GPU or an FPGA. So it's really helpful when you have one that's can surpass a GPU like that.
All right, let's thank the group.